Let's talk about fetch and promises and APIs and all that kind of stuff. All right, so we're gonna do this in a couple of different parts. We're gonna talk about APIs first as a recap. We're gonna talk about fetch in particular. We'll talk about promises in general. And we'll talk about Promise.all in particular. Any other API fetch promise related thing on your mind? All right. Yeah.
Sometimes I get confused, like when to break out of a thin chain.
Sure. So, like specifically, let's definitely talk about chains. I saw this morning some people were asking about like returning. Nesting is a pretty critical part of that. Chains, returning, nesting, ending. Cool. Other API fetch or promise related questions?
Is there shorter ways to request the fetch and return? Is there like a condensed version of that, or you have to do the full thing every time? I guess is what I'm wondering.
Sure. Great question. The short answer is kind of yes, kind of no. So we'll explore that. More things you want to make sure get covered in this.
Maybe if we could dive a little bit into more details about what a parsed response is.
A response versus a parsed response. That's a great one.
Sweet.
Other stuff you want to make sure mix it in here.
Talk about, or I guess just bring our prior conversations into this one, like when working with an API, where should you start brainstorming?
Oh, excellent. Where to start? What else?
Maybe a snack during this lecture here. Looks like a long one.
Damn straight. All right, this is a pretty big meal to get through before stand down. So we'll do our best. And hey, we still got 11 weeks, 10 weeks, somewhere in the 10 and a half weeks. So we can keep talking about this. All right, so let's start with APIs. So it's pretty normal to have your browser to use more than one API, and you might own one of them or multiple of them, usually one. And you might integrate with a lot of other ones. And what's kind of cool is that the API that you own might integrate with more APIs. For example, all the content for this program lives on GitHub, but the browser doesn't request that content from GitHub. The browser requests that content from like the Sika API. The Sika API goes to the GitHub API, gets all that data, brings it back, and then my API sends that back down to the browser. So like, yeah, all of your performances and all of my evaluations for your performances, those all live in an API that I built and own. And like towards the end of the program, that's like, you're going to be doing similar things. Think of it as like arrays and objects and stuff, except they persist somewhere. So they don't disappear as soon as you refresh your browser. And then other APIs that like Sika uses. So this is like the GitHub API. I also use the Gravatar API. It's where your avatars come from. I'm trying to think of other ones that I use. I want to say that there's a. I feel like there's some time API that I'm using that like keeps track of what the date is or something like that. Or just some time manipulation. Anyway, so like those are examples of like APIs that you might use. And other kinds of APIs that you might use. Well, let's take a look through the list. Where do we go? Let's go through that free API list and brainstorm some like kinds of things that you might be able to make with those. Hi, kids. All right, so we have all these different categories. Let's say we look at animals. Well, what kind of things do we have? Daily cat facts. All right, well, if you want to integrate that into your site, you can just throw some daily cat facts up in the corner. Adopt a pet. I've seen a lot of student apps around these get made. So like this is an API that provides like pictures, city, adoption information just in general about pets. So if you wanted to make an app that helped people adopt pets, the adoptapet.com people don't have to be the only people who have an app that does that. You can use their API also. And so here's a walkthrough of the different things that come back from that. So like for a particular shelter, think of that like a film ID or an episode ID or something. You could say, all right, the pets at shelter 3057, this will return the count of pets that they have. So you could use that to say, all right, as long as there are more than 0, otherwise you would say, okay, cool, they have, everybody's been adopted, hooray. So then the pets could be, we'll have a sort order. So it's like some of you were talking about like, oh, it sucks that like the Star Wars API doesn't have that. Well, they do have one. A URL for a picture of the animal. The dimensions of this. So you could use that to like dynamically set the size of something. Sex, age, all of this stuff comes back from that. So you could build your own pet adoption app without having to manage any of that data yourself. Or let's look at government. All right, so tons of open data. Actually, I'd be pretty surprised. Oh, so more of them than I thought. So this like HTTPS column is whether or not you can just make a fetch request to get it. So then you could presumably do it in real time. But like the Colorado Information Marketplace suffered from this for years, where they have all kinds of data that you can use to build apps. They even have a competition that they run every year. My wife was one of the finalists one year. But they have all of these like different pieces of public data. So like the COVID-19 data set. It's like map of locations. If you want to integrate that into your site, where are all the different places that like you can go to the Department of Human Services, or you want to map what people's different well-being and stuff is, or make a map of like the COVID cases in Colorado. We could go over here, and to access this data, apparently we go over here, and it goes to a broken link. Way to go, Colorado. So like the stuff that you get from that could range from an API that's indistinguishable from the Pokemon API. A lot of these government ones end up being just files. Colorado broadband coverage. It's just a zip file. So what you do with that, here's the crazy thing, it doesn't actually work any differently. You download this like JSON file or XML file or what CSV or whatever they end up giving you. Let's see what it is. XLS, come on, man, join the future. So then you would open up like this. And then take whatever you want out of this data, and then you would have to turn this into like JSON or CSV or something like that. Like a lot of government stuff works that way, and it sucks. Maybe this one is a CSV. No.
How do you turn it into a JSON file?
Very carefully. No, so like it's tricky. So like you would need to do that probably in some kind of manual way, or what you could do is you could take all of this and like make it a CSV. So that's just like one of your export options in spreadsheet software. If I say, all right, I want to export as, oops, probably needs to go through some conversion first. Yeah. Come on. Save as. There we go. So we save this as a CSV file. So then it's going to have these like things like, okay, how should we separate this out? Like all these different things. And then when we do that, it takes this particular sheet. And if I go over to documents and I look at this CSV file, let me open it up. The actual text editor. Okay, so now I have this data, and then I could write, oh, I don't know, a map function that I need something that can read this and turn this into like an array of strings, and then I can map through each of those and turn those into objects, and then I could parse that as JSON. So like there are automatic like tech ways to do this kind of stuff. It sucks. I would not recommend you do that in this program. But that's how you turn that into an API. Is you do that transformation, you make it a JSON file, and then like fetch doesn't need to be an external URL. It can be a file on your computer the same way that like you do images and stuff. You can fetch something from like a local directory, and at that point it's just JavaScript. So like there are some like government APIs tend to be more like that than other kinds of things. So let's take a look at this one. Here's a COVID-19 API. It's gotten 330 million calls. All right, and so there's the base URL. Hey, what do you know? Kind of just like the Pokemon API is. So we could make a fetch call to this URL and see that in Afghanistan, that's how many COVID cases we've had. It's got some other information, including their population, how big it is. So you can imagine already how we could just do some simple math on that and go like, this percentage of the population in Afghanistan has had COVID. And average life expectancy in Afghanistan is 45. So, God, that's depressing. And And so you could do just like regular mathy kinds of calculations to analyze something about that. And there's also libraries we can use to like plot this stuff on a map because, hey, they gave us the latitude and longitude of the capital also. So if we were making a chart, we could use that to like superimpose our thing on top of it. That would be an example of using an API. Questions about like that kind of thing. Oh, and the original question was like, how would you get started like when you find something like that? So let me find another one and we can kind of talk through it. Let's say I wanted to do like a recipe thing. All right, so this is giving us some examples of like how this thing could be used. So if I look at the recipes documentation, this schema, this is like the format of the data that you're going to get back. And it's all just in types. So if it's 0, it's a number. So there's a from property on this response. That'll be a number. There's going to be a hits key that's an object or an array of objects. Each object has a recipe key. Each recipe has a URI that's a string and a label that's a string and an image that's a string. So like we can infer that's an image URL. So it's got all these different things. So let's say we're building an app that lets you take a bunch of recipes and it shows vegetarian ones or something like that. So what you would need to find out is, can I figure out whether or not a recipe is vegetarian from this? Like what in here would tell me that? So maybe that's health labels. Well, can I, oh, there we go. I've got some there. Bingo, vegetarian. Neat. So now I know that I can get all of these recipes back, and then maybe I use .filter to make sure that I only get recipes that are vegetarian. And I go, okay, what actually comes back in each of these recipes? All right, well, an array of ingredient objects, I guess. So that has how many of them that I need, what the measurement is, and then like some kind of text description and how much it weighs or whatever. So then I go back to my user interface and I go, all right, what do I want my recipe card to look like on my website? So you write all those things out and you go, okay, do I have enough data available to do this? And some of that stuff you might get back directly from the API. Some of the stuff you might calculate. You go, well, I want it, I don't want it to be exactly like the quantity and the measurement. I want to combine those to just like the total amount that gets used. So you figure out, can I like wrangle this data in a way that gives me what I need to show up in my user interface? Or sometimes it's sneakier than that, where like there's something in my user interface where I'm not getting like that thing specifically, but with things that I do get, I can calculate the thing that I need. So like that's how you apply the getting started stuff to APIs. Is you go, oh, a recipe app would be cool. What do I want to put on it? What makes it a cool app? And am I able to get that data from here? And then like where mashups happen is, all right, oh man, like this has everything except a picture of the food. And so then you go back to the public APIs list and go, all right, if I have the name of the food, is there a like picture database of foods? Random pictures of food dishes. So are they truly random? Because that doesn't do anything for me. Can I request a specific one? I can request a random picture from a food category. Well, maybe that works. And there's some examples of like, different ways you could do that. Lauren, does that give you some ideas and direction? I think it was Lauren that asked that.
It does, but I didn't ask that.
Okay. Whoever asked the question, does that help? I'll take that as a yes. Back over here. Where to start with APIs? There you go. Start with your idea. You can like scroll through that public APIs list to like get inspiration. But fundamentally, you're starting it the same way. Figure out what you need to show on the page. Figure out how you're going to physically arrange it. Try hard coding it. Request, then move it from hard coded in HTML to like hard coded in JavaScript. Then make it a little more dynamic in JavaScript, where you're like, okay, can I, instead of just writing 3 for the weight on my JavaScript file, can I pull that from an external API? So that's a little bit about what these are sort of all about. More questions about APIs.
That's for our production website. If we end up on one that has the XML files, we probably need to make another choice.
No, I think you can. Fetch almost definitely has a parse XML. Does it? Oh, gross. That sucks so much. So what you do, so .text is an alternative to .json. It's saying, I don't, like, this is in some non-JSON format. Just give me the characters. And so that pulls out the characters, and then you need to, like, build a new XML object with it. And, like, that's how you would do it. It still works.
Choose a different one.
I would recommend a different one, but...
Yeah.
But yeah, it's 2 stupid lines of code, but there you go. More questions about APIs? All right, let's talk about fetch. Is there a condensed version of fetch? Fetch is the condensed version. So, quick history lesson. Generating an HTTP request with JavaScript in your browser, so not typing something into the URL bar and hitting enter, but having JavaScript make a request on your behalf, is more abstractly called an XHR request. And God, for the life of me, I can't even remember what XHR stands for anymore. Oh, that's going to drive me insane. XML HTTP request. There you go. And you might be getting a sense of how dominant XML was for so long. It was like a big breath of fresh air when we got JSON. XML HTTP request. Even when it wasn't using XML, they still called it an XHR request. And to wit, check this out. You've probably seen me do this today already. When I look on the network tab, XHR is one of the things I can filter by. So if I want to see every HTTP request that was started by JavaScript, not by like just loading things from the HTML page, those are the ones that were all triggered by JavaScript. It's an XHR request. So JavaScript for a long time has let you build XHR requests, and they suck. Oh my God, the XHR interface is terrible. Look at this. Oh, they've got a guide to it. Okay. That doesn't even do any of the parsing stuff. Like how we do fetch URL and then we're kind of done. This is what you had to do before. So you'd generate a new request object and you'd add an event listener to the load. You would open up the request and give it the method and the URL and then manually send it. And then to like do anything with the response, you would need to have like add an onload handler. Just so awful. So fetch was like, oh, browser apps are doing way more HTTP requests now. So we probably need a simpler interface. And so what they came up with was fetch. Now, the other side of the question is that, yes, there actually is a way, easier way to do this called Axios. It works a lot like fetch. But there's no parsing step. And your methods are like your HTTP methods are just JavaScript methods. So you say axios.get, axios.post, axios.whatever. You give it the URL, and then you just start chaining. I would not recommend using Axios just yet. We'll probably play around with it a little bit. It's built into Angular. But every single web dev in the whole wide world needs to know fetch first. But there is a shorter way to do that. That's what it is. All right, let's talk about this like response versus parsed response thing. So let's start by just making a request and then looking at something in the browser. So if I go to let's go to the LMS. So if I go over here and just make some fetch request, and then take the response and just log it, let's take a look at what we get back. All right, so that is an unparsed response. We actually get some pretty cool things on this that we may have need of in the very near future. This is where the status code is. This is where the headers are. This is whether or not it was an OK status code, so something under 400. We just get a property that tells us that. So like 9 times out of 10 when you're using this, it's because you're checking the status code. Did this come back as a 404 or a 500 or something like that? Because strictly speaking, those aren't errors. That is a successful HTTP request. It just didn't give you the thing that you wanted back. Those are different. So we have all of this. Ooh, but take a look at the body. Readable stream. Womp womp. Can't do anything with it until it's parsed. And the reason for that's kind of complicated. It's because not every HTTP request immediately gives you everything back. Everything that we're going to do for the rest of the program does, but it could be a stream of information also. You don't parse those like the same way that you would just a JSON thing. And so since there's different ways that you could do that, it makes you explicitly say that you want to parse the body first. And so if I do that same thing, but I maybe open this up and say if response.ok, So I got some kind of truthy value there. Then I want to return parsing the JSON. Otherwise, I want to throw an error. Oops, something I didn't like. What's wrong in here? Let's look at that error again. Oh, yeah, it's because I tried to parse it as JSON. And JSON doesn't come back if you just send a GET request to google.com. So it ends up throwing an error anyway. We want to do parse it as text. There we go. Hey, what do you know? It's the HTML for google.com. That's the difference between the response and the parsed response. The response is everything, status code, headers, like all of it. To access the data in the body, we need to parse the body first. Ask me some questions about that.
It's always going to be the case that after we do a fetch, we need to get through the response before we can do any kind of a parsed response. Is that the case, or can we just go directly to a parsed response?
So let's say you don't care what the body of the response is. A good example would be deleting something. All you need to know is whether or not it worked. You can get that from response.ok. No need to parse the body. So like in that case, maybe you don't do a response.json or anything like that because you don't need to. All you need to do is make sure that the status code came back all right, move on with your life. When you're getting back JSON though, and you want to do something with that JSON, yeah, you have to parse the body every time.
Cool.
Is it in how you wrote the code? Is how it returned as a parsed response? Which part of it was it?
Okay, so that triggered an HTTP GET request. Whenever that response comes back, then I look at whether or not it had an OK status code. If it does, it parses the response. Otherwise, throws an error.
So is it the dot text that parses it?
Correct. So we've got a couple different
Okay.
options. If I do response.json, it's going to error out because this isn't JSON. This is HTML. So there's like three common ones that you would do. The only one you're going to do in this program is .json. But if you did get some data back that wasn't JSON and you wanted to use it, .text would give you access to that. Or if they send you back a file and you want to do something with that file, it's .blob. It's an acronym for binary large object. But it's like a blob is like literally ones and zeros. It's not text, it's not anything. The only one you'll do in this program is parsing the response as JSON.
And so this parsing response process, especially when we're talking about these projects that we're coming up into, this is going to be like crucial for getting any kind of real data out of an API, right?
Yep.
Because the Pokemon content is only going to be found in that parsed response.
Correct. But whether or not the API is down, that's in the unparsed response. So if you're being thorough, you're checking that status code before you parse something.
Cool.
If I draw it as a picture, it looks like this. Your browser is chewing through JavaScript, comes across a fetch request. It goes off to outer space, calls that to some API. Now, at this point, the rest of the code has to keep going. This could happen instantly. This could happen a second later. This could happen 25 seconds later. Who knows how long this request is going to take. It's going to a completely different server in another part of the world. Like at some point, you're up against the laws of physics on that. So things that don't depend on this API response coming back, those keep going. When this response comes back to the browser, it goes, oh, by the way, this can keep cranking, but I also had some stuff that were dependent on this response. So those all go there. That's the then catch kind of stuff. We'll talk about that more in a sec. But this response comes back with a status code and headers and a body. We can't access the body right away, though. It needs to be parsed because the browser doesn't know whether or not we got JSON back or the binary beeps and boops from an image file or a movie file or something, or an XML file that we need to parse. So it needs to go through that step, which could also take who knows how long. If that XML file is 50 megabytes, well, we don't want to like lock up the browser while it's doing that. So that's why that's an asynchronous thing. So it does that. And then once it's done that, then we have our then chain with all of the things that depend on this being done. So that's the fetch. That's the first dot then. That's the second dot then. And then any other dot thens start happening over here. More questions? Talked about that, talked about that, talked about that. Anything else before we move on to promises?
Yes, really fast. What does it mean when we find an API and it's considered a REST API?
Ooh, that's a great question. REST is an acronym for Representational State Transfer. RE.
So what would be RESTful?
An API that conforms to the REST standard.
Okay.
It's also why, like, the thing that we use to test REST APIs is called insomnia, because you're not getting any rest. There's all kinds of, like, little jokes about that. So REST is interesting. REST was the doctoral dissertation of a guy named Roy Fielding. And it was super influential. It's not a technology. It's just a way of organizing APIs. So this idea that we have HTTP methods like get and post and patch and put and delete, and those are describing the action that we take on a resource, that's REST. It's not the only way that we could do HTTP requests. In fact, it was the way that we did it before was stupid AF. Every single API was completely different. Like, as not just like the format of the data, how you requested stuff. You might make one request and they give you back a little token and you hang on to the token and you send the request, and the next request gives you like a menu of different things that you're allowed to do, and the HTTP verbs and the URLs are all completely arbitrary. Sometimes they're expecting data to get sent over in the query string or the HTTP body, or sometimes you send it one piece at a time in subsequent requests. It was absolute nightmare. So REST was supposed to be a like sane set of standards for, all right, how do you add something to an API? Well, you send a post request to the URL that has the plural version of whatever the thing. So you're trying to add a new user. Well, you make a post request to /users. You want to get a list of all the users. You send a GET request to /users. You want to get a particular user, then it's like, all right, so we have post users to add something. We have get users to get all of them. We have get users / whatever that user's ID is to get a specific user. We have like put or patch /users / some ID. Delete a particular user. So this standard makes it way easier to work with APIs. If everybody kind of organizes their stuff this way, this is REST. So if your API kind of works this way, like the Pokemon API, where we have /Pokemon, /Pokemon /Pikachu, /abilities, like all of that stuff, that's a RESTful API. It's something that's kind of organized this way. Great question.
Thank you.
More questions about APIs, fetch, before we talk about promises?
Do you recommend doing your const variables up at the top or within?
For fetch?
Yes.
So that's going to depend on scope. So I'm going to punt that question over to promises, but I promise I'll get to it. Other questions? All right, let's talk about promises. Promises are the most difficult JavaScript thing that we will cover in this program. So if you've had a hard time with them, you have 2 ears and 2 eyes connected to a beating heart, because it's a complicated idea. The gist of it is this. Most of the code that we write is synchronous. So it starts at the top, works its way down to the bottom. Even when we use functions to kind of like change the sequence, it goes to there and there. All of this stuff still happens in order. It never needs to wait for anything. Map, filter, find, for loops, any kind of loop. All of those things are synchronous. We also have things that take who knows how much time. So these are things like network requests, reading or writing files. Literally just waiting. So like I want something to happen after 3 seconds. That's waiting. User confirmation. So when you go to a site and it goes, can I see your, have access to your location? Like, it's not, your browser doesn't freeze until you answer. It's waiting for you to do that. All this stuff is async. So the problem is your computer doesn't understand the concept of waiting. If you tell it to wait for 3 seconds, what it does is it will take a CPU cycle and go, are we done yet? No. Cool. How about now? 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 It checks it, a billion times a second until like the thing happens. That's the only way it knows how to wait for something. So that's why, like, if you try to do any of these things synchronously, you make your network request, your browser freezes until the network comes back. We're reading a file. Might be a very big file. It might take seconds for that to like load up. All right, you want your browser to freeze while you're doing that? All right, I click a button, a little toast pops up in the lower right corner of your screen, and then a couple seconds later it goes away. All right, but you can still use the site while it's waiting for that to go. User confirmation. Hey, do you consent to your data being used for whatever? Like, it wouldn't even be able to process your response if it was trying to do all this synchronously. So what we need to do is turn this kind of thing into something where, all right, these things over here need to happen in order, but none of them are network requests or file access or anything like that. They trigger off some of those things. And when that happens, there might be things that are dependent on that wrapping up. And some of those might even have things that are dependent on something else finishing. And something over here. The order of these matters, but only relative to other parts of that. So the complexity of like how all that gets managed, your browser takes care of all of that. You just need to tell it which things depend on which other things being done. That's promises. So what that ends up looking like is something, something, fetch. By the way, whenever that fetch finishes up, use the data that comes back from it to do this. But these things don't matter. These things don't use anything that comes back from that fetch. Anything that does use what comes back from the fetch happens over here. That's what .then is. Whenever this asynchronous thing happens, you can keep going, but don't do any of these things until that's over. Make this HTTP request, and whenever it comes back, execute this function. That function ends in another asynchronous thing. Okay, so whenever that wraps up, then execute this function. That's what the thens do. And so you can chain those. If another asynchronous thing happens inside of that, .then. Another asynchronous thing happens inside of that, well, whenever it's done, do these things. Each one of those. .then, .then. And all of this is the body of those functions. And the way that you pass data between them, whatever returns from this function goes over here. Whatever returns from this function goes over here. That's what the chains are. Ask me some questions about that. That's a heady one.
How do we know when the returns stop so we can stop putting dot thens in?
When you're done having asynchronous handling. So if we look at that in code, and so I fetch from the recipe API. Whenever that request comes back, what fetch will return is the unparsed response. So that's what like the fetch promise of it, like returns somehow somewhere is that. And then if I do this other asynchronous thing, the result of this, what that evaluates to, is a parsed response. And then I can do whatever I want with that, including at that point, you don't actually need to return asynchronous things. Check this out. Just keep doing that. Totally legal syntax. But most of the time, what we're looking for is, all right, I did an asynchronous thing. Whenever it wraps up, take whatever that evaluates to and let me do this. This could also be any number of other like synchronous things. For example, checking whether or not the status code came out all right. So if that did, then do that. Otherwise, throw an error. So this parsed response, well, maybe I need to map and filter and map and reduce that. That's all synchronous, no problem. Okay, well, what if some cool result is exactly what I need to make my next API request? Like food image API URL. So I needed to do some kind of transformation to get like the name of the food or the food ID or whatever. So then I use that to make another asynchronous request. All right, well, what depends on that request coming back? Well, anything that would need that image. So also a parsed response. And that's something like, we're going to do the exact same thing. Or also a unparsed. And then that's going to dot then again, also a parsed response. And like that will be the food image stuff. So we have to keep saying what depends on the previous step being done. Well, to have the food image thing, parsing the HTTP response needs to be over. To parse an HTTP response, the HTTP response needs to have come back. It was launched by that. Okay, but to make that request, I needed the food name or whatever. Okay, well, that came from that. But to do that one, I needed this parsed response. To get that parsed response, that asynchronous thing needed to be over. And to get that API response back, I needed to launch it in the first place. Chain of asynchronous things. I like to think of it as some async thing, like a fetch request, and then each of these are like the thens. Just big blocks of data. Each of these tends to end in another asynchronous thing. They don't technically have to. You can do synchronous things from here on out and just return those, and if that helps. But the only reason you need to do this is synchronous, 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 async thing. Synchronous, 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 async thing. And then more synchronous stuff. And each of these are separated by thens. Also, these boxes, these are scopes. The stuff in here can't see the stuff in here or the stuff in here. The stuff in here can't see the stuff in here or the stuff in here. The only way we can communicate between these is whatever this returns eventually becomes the input to that next function. You guys are being quiet. Ask me questions.
And just to clarify, you can have synchronous code outside of that. So like, even though the .thens are waiting for certain things to come back, you have other code on the top or bottom of that running simultaneously, basically?
Totally. So we did these synchronous things until the asynchronous thing happened. And what will happen almost every time in almost every browser, this stuff keeps going. It actually finishes doing all of the synchronous stuff before it even checks to see if this has come back yet. So if I, over in the code, have some other thing, even if it's a lot of different things, it's going to fire off this HTTP request. Then it's going to do this. 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 And then it'll check to see if the response has come back. If it has, it'll do all of these things.
Awesome. Thank you.
Here's a metaphor that sometimes helps. If it doesn't, don't worry about it. We're in a restaurant. We have the kitchen. We have those, like, I've never worked in a restaurant. We have that silver flat thing where they put the food when they're done. I don't know what it's called. We've got the dining room. Then you have a server, not web server or anything like that, like a restaurant server, who runs in a circle. They run over the dining room, see if there's like any synchronous stuff that they need to do. They check with this table, they check with this table, they check with this table, they check with this table. Then they run back to the kitchen and go, hey, is there any food ready? If something's ready, they run back to the dining room, take it where it needs to go. Meanwhile, they're collecting more orders. So they drop off something there. This person's food isn't ready yet. This person placed a new order. They run back to the kitchen. They drop off some orders. They see that one of those things is ready, so they come back. This is what your browser does. It takes everything it can do, knocks it out, takes any asynchronous requests, drops them off at the kitchen, sees if any of the previous asynchronous requests are ready yet. If they are, runs back to the dining room. But they don't have multiple servers. There's not 8 waiters who are just running back and forth in the kitchen. That's how Java works. JavaScript, there's one very hard-working waiter who's just running in a circle all the time. That's why we handle asynchronous code that way. Like I said, if that metaphor helps you, please keep it. If it doesn't, don't worry about it. More questions? Onward. Okay, so we've talked about these chains, and we've talked a little bit about returning. What's parse response? Parse response is going to be whatever was returned out of the last one. If it's a promise, the promise gets resolved. What is also an unparsed response? Whatever was returned from the previous block. If it's a promise, it gets resolved. What is also a parse response? Whatever was returned from the previous one. That's this relationship. Now, you might note that in this block here, I actually don't have access to parsed response anymore. That's in this scope. It's only in that scope. Yikes. The solution to that is if I need something that uses the result of this fetch and parsed response, I have to nest the promises. I can also dot then here. So then I am no longer doing any of this. But now I have access to both of them because they're in scope. Remember, boxes inside of boxes. This whole, all of these like then chain things are still inside of this first one. That means they have access to both. Nested promises. And I can still dot then off of that. Because this whole chain that I'm returning is a promise. A chain of promises is also a promise. That means I can take the result of that. This stuff is in scope here. It stops becoming in scope again once I do anything else off of it. But if this down here needs both of those, for example, it needs the Star Wars API response and the OMDB API response. They have to be inside of each other, like that. That specifically is the single hardest thing we'll do with JavaScript in the entire program. You wrap your head around that, you've cracked the code.
If it's the case that you want to use some kind of promise later, like the unparsed response, couldn't you assign it to a constant or a function and put it on the global scoping? And that way you can just pull it whenever you want?
Totally. So we could have done that. If you want to make me mad, you could have
Never mind.
some container. That's fine. So you could initialize something up here, or just something that's in some kind of scope. And now we could say, let's see, let's say we're not doing it this way. We're going back to doing it this way. Okay, so let's say that we do it this way instead, but I still want to have access to whatever. Yeah, I can totally do that. So what was that? What do I call that? Some container. Yup. And then down here, yep, that'll totally work. No need for the nested request.
But you would rather us not do this.
Like, it's honestly, when you're learning, totally fine. The reason that like I cringe about it a little bit is that then these boxes aren't self-contained. As soon as these boxes start working with things that are outside of the boxes, like here, they become really tied to that. So this right now, that's not relying on anything else. I can make that a standalone function. I can put it in a different file. I can test it independently of anything else. But like, somebody mentioned at some point spaghetti code. That's how you start getting spaghetti code. Now, this in particular is not that bad, but it's a drug. You start getting addicted to it. And then you start having all these little containers out here to manage all of your flow. That's the danger of them. But no, like this specifically, it's probably easier to follow than the nested promise was. And also, you should probably learn how nested promises work.
Got it.
So no, I would never kick something back, at least at this point, if you used a trick like that to get around doing nested promises. But like, this will click with you. I promise. Nested promises will click with you sooner or later. And if you don't keep trying to wrestle with them, they won't click. If you do keep trying to wrestle with them, one day you'll go, why did I ever think that was hard? Because it's actually not a complex idea. It's a very simple idea, just a weird one. Ask me more questions about this.
you have multiple sections on a web page that you're trying to do with different responses from, say, different articles or movies or something,
Yeah.
I guess you would do a separate fetch for each.
You'd have
Okay. Okay.
to. So like you can use that as part of your like, how do I get started kind of rubric also. Is like, all right, I have 3 different APIs. Like there's no, like you can't combine, you can't hit 2 different websites with one fetch request. So you go, okay, at a minimum, that's going to be 3 different fetch requests. Does the order matter? Are they 3 arbitrary order and I just need to combine them together? Or do I need to use data from one as part of the request from the other? So you go, I have 3 HTTP requests. What order do they need to happen in? Or does the order not matter at all? That's a pretty good troubleshooting technique also, or getting started technique. Because like the OMDB API, you can't request that poster unless you know what movie you're requesting a poster from. All right? Do I know what the name of a movie or whatever is ahead of time? No. I get that back from the Star Wars API. Okay, so that means that I need to request something from the Star Wars API first, and then I can use data that I get back from that to make another request to the OMDB API. Okay, do I need data from both of those at the same time? Yes, I do. That means it's a nested promise. And we're getting a little long on time, but really the last piece of this is Promise.all. If I were to put that in the exact same framework, can any of these requests happen at the same time? If the answer is yes, that's Promise.all. For example, I have a movie. I need the characters from the movie. Okay? Can I get the characters without knowing what the movie is? No. So, drawing that out. I know I need to make a characters request and a film request. Can I get the characters without knowing the film? No. So that means that those are like order dependent. That needs to happen first, and then that. Okay, can I get all of the characters in one shot? Like, is there one URL that I can make a request to that will give me all the characters from this film? No. So that means I need to request all of those separately. If there's 6, or if there's 3 characters, that's going to be 3 HTTP requests. Okay, do I need to make those sequentially? Like, do I need data from one character to be able to make a request about another character? No, they can happen in any order. Okay, that means I should bundle all of these requests up in an array and Promise.all them. Okay, well, Promise.all evaluates to a promise. So I can take, so then the next question would be, do I need to have data from the film and data from the characters at the same time? Yeah, I do. All right, that means that all of that needs to be in one scope. So that means it's nested. Okay, let's say I need to do something with that needs to wait for both of these to be over, but it doesn't necessarily need to use any of the data from any of these. For example, like knowing when a loading indicator should go away. Okay, well, if all of this, if I return that and return this Promise.all, then I could chain off of that and go like remove loaders. Because Promise.all is just another asynchronous thing. And if we look at it in terms of like this, it's not any different. But if this is returning an array of promises with Promise.all, then the thing that gets passed is the resolved values of all of those promises. Just as an array, in the exact same order that you put them in. So if you have 3 fetch requests in there, you get 3 resolved fetch requests from each one of them. Well, since we need to like parse all of them, then we could map over those to also put the like parsing step in there. And then that's a promise too. So that all resolves to an array of 3 promises resolves to an array of 3 values. That's all that it is. So over here, that might be, I'll clean this up a little bit. Okay, get rid of that, get rid of that. Okay, so let's say that also an unparsed response also a parsed response has some array in it. And I need to make an HTTP request for everything in that array. Okay, well then I just need an array of promises to do. So to do that, hey, that's transformation. I could take everything in there and turn that into like fetch some item. And then parse it when it comes back. Like that.
And that's tying the 2 responses from 2 different APIs, or is that just?
No, that's unrelated.
Okay.
So that's just
Okay,
because one of these things contain some fictional array, and we turned that array into an array of promises that are these like parsed HTTP responses. We don't have them right away because they still need to go to space and get their shit back and parse them and all these other asynchronous things. So that array of objects turned into this array of potentially parsed HTTP requests. So then if we return Promise.all some requests, then the thing that'll come back from that is some responses. And that'll give us the results of these. If there was 3 of them there, these will be their parsed outcomes in the exact same order. And like, it doesn't even need to be all this like nested shit. If I just have, if I want to get 3 Pokemon, okay, I can take an array of 3 strings and turn it into an array of requests. So that'll be names.map. Take each name and turn it into a fetch request. That is pokeapi.co/API/v2/Pokemon/whatever that name is. And then parse it. Okay, so now this is an array of requests. I don't care, none of those depend on each other. I don't care what order they happen in. They just all need to happen. So I can Promise.all all the requests at the same time. And then Pokemon list 0 is going to be the Pikachu object, the Bulbasaur object, the Charizard object. Absent all of the other like promised sequence stuff, that's all Promise.all is. Lets us do a whole bunch of promises at the exact same time. Questions? Okay, we talked about promise chains and what the returns do, and nesting, and ending, and the scope of these, and Promise.all. One last thing I'll throw in there is catch. Catch is pretty cool. Catch is like the advantage of then catch over async await. If at any point in the entire chain something throws an error, it stops, goes to the catch block. Lets you do something, lets you alert the user that something went wrong, lets you try again, lets you do whatever. And if you have a bunch of promises, you can throw one at the end, and if any problem happens at any point along the way here, it'll go to the catch block. And you can also like have more than one. So that will catch any problem here. That will catch any problem here. If you want to intentionally tell something that it's a problem, throw an error. And that will log WTF.
If you don't throw an error and an error just happens naturally, is it already have a message that it's going to return?
Yeah, it'll be whatever your browser calls the error. So it'll be like all the same ones you see in red in your browser, where it's like syntax error, unexpected character in position 0 in the JSON thing. All of those ones, that's what the built-in messages are.
Gotcha.
And what sucks is if you leave these off and don't do that at all, you probably ran into this. Something can be broken and it just doesn't tell you. Like, that's probably not what you want to happen. And so even just for your own debugging, just throw a catch on the end. And if that's another thing where that's kind of all you do throughout the program, that's fine for these 16 weeks. Just toss a catch down at the end, and it'll let you know if anything went wrong.
Is it at the end of each block, or is it just at the end of all of it? So like if
The
you
entire
were to
chain.
put a catch into const, would the one at the bottom catch something if it happened in the const request as well?
Any part of the body of these, this function that you pass into each of these, if any one of them has a problem, it stops running that block and just jumps right to the catch handler. And if you have one here, problem happens 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 here, that's where the sequence goes to. Does that answer your question?
So that's for that function, but where it said Promise.all, would one at the bottom in that function catch in that block, or do you have to have catches in each one of the bodies that you're?
No, you need one for each one of the chains. So like
Okay.
this catch wouldn't catch any problem with this. that would need its own catch.
Okay.
And these aren't going to catch any problem over here. Just needs to be part of the chain. All right. Let's call that good.